Okay, if you remember, one of the things that I tortured you with a while back was this class that what it did was it took a URL, and from that it was supposed to identify what the unique words were. So here's an implementation of that. There are basically kind of two slight changes from what I had asked you to do. One was the original constructor had this sort of start and end string, because if you remember, the text files that we were looking at had these had front matter and end matter that we weren't going to be interested in, but in other cases we might want to read the whole thing. And it turns out that the logic that said, okay, skip over to the start, skip until you encounter the start string, and then continue until you encounter the end string to skip over those. It turns out that, where the heck was it? Yeah, so if I added just another constructor where you just give it the URL, and that would use the default start and end string. So if you have an empty start string and an end string that is unlikely to be encountered, so I had this one that just sort of none with stars, then it'll more or less read the whole thing. Okay, so let me show you the objective here. So the idea is to have a graphical user interface version of this, and this is it's a stripped down one. It doesn't have a menu the way that we talked about yesterday. It doesn't have fancy exit stuff. It does have this where we'll close it by just closing the window, but since we have that reusable class, the window closer, we can use that to at least be reasonable about that. Again, most of the other options, such as disposing, that is closing the window, releasing its system resources, but having the program running still where you can't do anything with it, that's not terribly useful. Or just having the whole thing shut down without any confirmation from the user, that's not very friendly either. So you almost always want this kind of thing. Now, when you get to be a little fancier, which we won't get to in this iteration, then you will typically have some kind of Boolean or Boolean-like variable that says whether or not there's been a significant change. So for example, like if you're editing a Word document and you make no changes and then you exit, it will exit without any confirmation. Why? Because nothing has changed. So think about what that would require. I mean, again, some programmer implemented all of that. What that would require is that you kind of know when something has changed and kind of keep track of that. So again, it's just it's not rocket science, a little bit of overhead. If that's required, then I feel that you all know how to do that. Okay, but in this, what I'm focusing on are kind of a couple things. One is we're going to get our input either from a file or from a URL. So I have two buttons for that. And then what this is going to do, it's going to use this class that we'd already created called unique words. Again, this is from a couple assignments ago that didn't have a graphical component. And if you recall, when we ran that, we had to kind of type in enter in some fixed way what it is we were going to read. In this case, a URL. But since, what did I do? Oh, no, we're here. Since the URL class in Java exploits the fact that file, the word file, is a legitimate URL protocol, as well as HTTP, HTTPS, and there are a whole host of others. But those are the three main ones that we can use to basically grab a text file and then process it. But all the heavy lifting, all the processing is going to be done by this unique words that you all have. Again, this was my version of it. Your versions were all more or less the same. And you know, it has two things. One is to when you instantiate it, you sort of set this URL, and then you call read words. And then the one difference between this and the assignment is that I'm now throwing this IO exception. Remember when we set up the scanner, it could potentially throw an IO exception. Why? Because if you're trying to open something that's either not there or something where the scanner can't process it, like a binary file, then it will throw an IO exception. Now, in the in the exercise I had you do, we caught that and then basically bombed out. The thing is that in a graphical interface where we're going to be kind of doing this multiple times, you don't necessarily want the whole program to kind of crash and burn just because something like that happened. Just because what could cause this to happen? The user could kind of try to put in something which either isn't there or has trouble getting. In that case, you don't want to shut down the whole application. You want to basically let the user know about that, and that's how we'll do that. The other thing is that I added a setter for the URL. So that's just these two minor things. This is probably something that should have been there to begin with. Again, when I kind of invent these ways to torture you, I try to kind of minimize the pain, as it were. You may not believe that, but I try. I don't always succeed. Anyway, the point is that this is a totally non-visual class, and to me, the power of concepts like model view controller is that something like this, an instance of this class, is the model with a capital M. You know, the way that, as we talked about, the way Swing thinks of a model is kind of has more to do with the state of the graphical interface. But this is kind of a model a little bit more the way a simulator may think of it. And in fact, at some point next quarter, we'll kind of look at something similar in a simulation context. So the idea, again, the way it's supposed to behave, is that we can either read from a local file or read from a URL. So the read from the file, now this is something that we have done. So open up a little file chooser, maybe choose a local file, and then it's going to now what I did here was I just dumped the toString from the unique words class, and it listed all the unique words. Now in this particular case, I was also processing the front and back matter. I wasn't worrying about skipping the other stuff. Again, that was just for demonstration purposes. So what it does is it displays the unique words here, which it gets from that unique words instance, and then it also at the very bottom lists how many there actually were. So if I want to read from another file, then it does the same thing, only here was a smaller file. It just had a smaller thing. Here's a yet smaller one that has 10 unique words. Now the other is to read from a URL. Now as far as URL goes, let's see what one of our sources for these is our our friends at the Gutenberg Project. So if we just kind of pick a text version of it and copy the link location and come back to our application, then if we read from a URL, what this is going to do is this is going to throw up one of these, a little dialog that's going to ask for input. And again, I'll show you how all this is, and we can just command or control paste in the URL that we had, and it'll take another, but again, it lists the URL in the title bar, and then this is from the toString of the unique words again, and it just lists the unique words as that it processed. In this case, we had 6,466 of them. Again, this included the front and back matter. One of the nice things about the URL is that, as I said, file is a legitimate protocol, so I can put in file and if I know I could also paste in one here. So here I'm putting in a local file using the URL, and as you can see, that works there. And that works because the URL is coming into the unique words, but as a file URL, and that works the same whether it's HTTP, HTTPS, or file. And if you have access to anonymous FTP, you could in principle use something like that as well to a text file. So, that's one of the nice things about a class like Java's URL, is that it is agnostic and therefore makes this an instance of this class agnostic as to where its data is coming from. And that's an important kind of generic thing. In other words, this class is not handcuffed to where things are coming from. It's agnostic to that. As long as you can put it into a URL, which is, again, just has become a standard way of describing where a resource is, then any legitimate URL that will provide a stream of text can be used for this. And there are other protocols that can be used as well that are legitimate, that subject for another class. But whatever that is, if that can produce a stream of text, then that can be used here, and that's a pretty nice thing. Okay, so now so what we have looked at is this is a text area here, and actually as a text area, it has by default some of the characteristics that we're kind of used to, even though they may not be necessarily displayed. So, for example, I can, even though this is not editable, I can select text, and if I do a Control or a Command C, that will copy it into the clipboard, and then I can paste whatever I've copied into somewhere else. In other words, the text area as well as the text field works with the clipboard on your system. Now, without any further extra stuff on your part. So again, I can sort of select stuff. I can and I can copy it. If this were editable, I could do a paste. That's kind of what I did over here. Now I don't have the URL in my, but again, what I did here was I chose one of these texts and I copied the link location and then just did in my case, a command, and on a Windows it would be Control V to paste it in. And then and it was able to do that. So the swing components provide out of the box a lot of functionality that we're kind of used to. Now, what we have covered, we've covered how to take that text and put it into a text area, which is what's here, how to put that text area into a scroll pane, which is what causes this to appear. This label down here, again, that's something that we've covered. How to basically just connect this as a window listener to an instance of that window closer object. How to open up a file chooser and work with a selected file and be reasonable whether it cancels or not. So what is there left? What's left is, up until now, all of the swing examples we've seen have been completely self-contained. And one of the different things here is the use of this external non-graphical file that does the main logic. The importance of that as a design is that you in all cases, you want as much as possible to separate the sort of the abstract logic, the algorithms, if you will, from the user interface. That's so. How do we do that? We'll get to that in a second. And then the other piece is just basically. You notice here, I bring up this little box here. This is literally just a one-liner. How to do this. So we will see how to do that. Okay, so most of this we've seen. You have this unique words is a class that you understand, or at least should understand, because you've written one of these yourself. Excuse me. Okay, so let's take a look at our GUI class. So I called it Unique Words GUI, just to emphasize the connection with unique words and the fact that this is going to be kind of a GUI. A couple things I've added just for laziness. I put in static variables that are final as the default. This is going to be the default size of this. So again, just sort of laziness. When I instantiate it, when I initialize the components, again, I set the default close operation. I have a window listener for the window closer. That's all that it takes to have the confirmation dialog when you try to close the window, and then here I'll set the size to the default size. And that can be overridden in the main method should you choose. And as you've noticed, if I allow this to be resizable, I can also change the size if I want. Okay, so here the open file button and open URL button, those are J buttons. So I have these as instance variables. That's all stuff that we've covered before. Here we have the number words label. That was the label at the bottom, and it was getting its data from how many words there, and that was a getter method in the unique words class. So here's well, it's going to be yeah. Here we go. We have an instance variable for unique words, and it needs to be an instance variable because we're going to have 3 different inner classes that are going to be need to have access to this. Okay, so all the configuration is all fairly straightforward. We've done that before, so you can kind of look at that at your leisure. But there's nothing. The only thing that I threw in there was I added a tooltip to the button. It's actually to both buttons. And that's something you can do to pretty much every component. You can add what is a tooltip? A tooltip is what happens if you hover over a component, a little some text kind of comes up. That's kind of a nice thing to kind of remind the user of what that thing is. So to be kind to your users, you put a tooltip in that says, if they want to know, what does this thing do? And then the tooltip will hopefully tell them. And that's how you do it. And they set tooltip text is something that almost every component has. And it has it because it gets that almost for free thanks to the inheritance class hierarchy of in object-oriented design. And that's one of the advantages of doing things that way. Okay, so now because we have two different buttons, there is a design choice here. I can create one action listener that will listen to both buttons, but the thing is, because the response is different depending on which button gets clicked, I would have to say, if you click this button, then do this. If you click this button, do that. Or, now, the other option, which actually would be slightly preferable, is to have the same display, regardless of whether it's a URL or a file, and then have like a little browse button. That would be another option. What I chose was kind of the most straightforward way, which is to have a different action listener for each one. In other words, if you click on this, one action listener is going to hear it and show a file chooser. If I click on this button, the URL button, it will throw up a little dialog that will allow me to enter what the URL is and then process it from there. So this we've already done. So the open file listener is the one that's going to display a file chooser, and again, we utilize this sort of lazy instantiation that we talked about. That isn't always, if for some reason not everybody's comfortable with that, if you're not, then that's fine too. The alternative would be to write a constructor for this inner class and have that constructor instantiate everything that it needed. Which one's right? Yeah, they're both equally valid. You can make a case for either one. Since at my age I tend to be very lazy, the idea of lazy instantiation is appealing to me. So you guys are younger and full of more energy, and so you, you probably don't have to be as lazy as me. Okay, so we've been through kind of, you show the open dialog, and then you check to see whether did the user approve it or did they cancel it. And if they approved it, then we'll show you. In the previous case, the action listener was also a runnable. So we were kind of using it to both respond to the button and do the run. Here I've separated that out. And the reason I've separated that out into a separate runnable, which is read and count words, which is the runnable, is that because I chose to have two different action listener inner classes, they both needed to basically run the thread that would read in and process the text. So they both, if I were to use the same design as previously, that is to have them be both action listeners and runnables, I would have to duplicate this code basically. And again, that violates the principle of laziness. And so I create a separate one. Again, which one is correct? It depends on the context. In the case where more than one class, more than one instance needs to have access to this thread, then you probably need to separate it out and do it that way. Similarly, the executor service now is not an instance variable of the inner class, but an instance variable of the outer class. And that allows me to have just one instance of it instead of having one for this class and one for this class, or one for this and this class. I would need one for each of those, but since at any given moment I only need one period for the entire application, then that speaks to making it an instance variable for the outer class rather than the inner classes. Let's look at this runnable now. So here, again, an instance variable in the outer class, unique words. Remember, that is an instance of this unique words class that we'd already written, more or less. And again, I'm using lazy instantiation here. So rather than instantiate it right off the bat, I'm saying I'm not going to instantiate it until I actually need it. So, and here I'm going to instantiate it with the selected URL. Now, and again, I wanted to make this example as minimal as possible. So if it's not null, then what I do is I now set, remember I added that setter for the URL. Now I'm setting the selected URL. What I've done here is, what I've omitted is that because we have that front matter and end matter that we wanted to deal with, what I really would need to do next, if I were kind of proceeding with this, is to allow the user to enter that front matter delimiter and end matter delimiter if they wanted to. In other words, here, this is going to read the entire thing, which isn't necessarily what we want, but that's kind of outside of, how should I say, I'll leave that as an exercise for the interested student if there is one. So again, this is the runnable. So this will be executed by the executor service. And what does run do? Well, first we're going to set the text. We're going to clear the text in our text area. And then now we're going to either set the URL if we've done it before, or instantiate it with the selected URL. Then we're going to read the words. And after we've read the words, then this instance now has a set which has all of the unique words, in this case in a sorted form. So in this case, I chose the lazy way of, I'm going to, here I just got the toString that I'd written. I'm going to set the text in my text area to what that toString is, whatever that is. And then remember the number of words label. I set that to the number of unique words. Now here's the thing is that I could pass it a URL that would cause an IO exception. Remember that? So here's where I need to catch that. And I'm going to catch that and show a message dialog that says the URL was not found. So those are some of the things that I need to do. So for example, okay, so here's a non-existent URL, or the URL that doesn't point to to an actual text file. And so what I need to do is I need to say, hey, all right, so it says URL or file not found. That's the message, and then I say, here's what you entered, and there's nothing there. Okay, how did I do that? A one-liner again, JOption pane, which is a very robust method. Bless you. It should show message dialog. And it says URL or file not found, and I give the selected URL. So if I give it a bad one, then it basically says that. What else can go wrong? I could just give it gobbledygoo, which can't even be parsed to a URL. And so there, I want to say, oh, what you did is not a URL. Now, if I don't do this, if I don't do something like that, notice that there's no, normally you'd see this sort of sea of red out here where there's an exception. So what happened with that? Well, that happened when I caught the malformed URL exception. So let's look at this. This is the action performed for the Open URL listener. Okay, now here what I'm doing is, again, let's look at what shows up here. I just have a little modal dialog that says enter URL, and I can cancel that or whatever. But the way that works is when I say show, it's something called show input dialog, and it has some various options. So this is the parent. This is the title. This is just sort of another little message, and then if I say plain message, that's what kind of takes the icon out of it. Remember, otherwise it's an annoying icon. So with this one magic incantation, I get something where I can enter. Now the result from that, if you remember in the other cases, the result had to do with what the user, whether the user chose the OK or the cancel button. In this case, the result is whatever the user typed in to that text. So anything that the user typed into this text is going to come back as the result. And so that result can be, if I don't type anything, it's going to come back null, or if or it might come back as an empty string. So either way, if those are the case, I want to ignore it. Other than that, if the user has typed something, then it could be a legitimate URL, but it might not be. So what I try to do is, the first thing I do is I take that and I stuff it into the constructor for a URL. And if that doesn't work, if that's not a legitimate URL, because the constructor for that tries to parse that and figure out whether or not it's a legitimate, it has at least a legitimate protocol. If it's not a correctly formed URL, it'll throw this malformed URL exception. Again, if I don't do anything, it'll just kind of blow up on me. And so here, I'm going to show this message dialog and then return, because it's like, hey, you entered nonsense. Here's the nonsense you entered. I'm not going to accept it, and try again. If you want to be a little bit, if you want to save the user some clicks, what you could do instead is if they enter gobbledygoo, when you say OK, you could go back to showing them the dialog again. That would require just a little bit more code here, not rocket science. I mean, again, think of how you might do that. Okay, so this message dialog, that's one of the new things. The showing the input dialog, again, that's yet another. And let's see, did I? And again, so what I'm doing here is I'm just doing a Command V, or on Windows it would be a Control V, because I had this the URL for this one file in Gutenberg in the clipboard, and it provides that and does the count. So in addition to just just a few extra little swing things about this, the main takeaway is how to combine or wrap, if you will, a user interface around an essentially non-visual algorithm. So here the algorithm is the one in unique words. Where is it? which is all here. So here's this read words. We're reading text, we're processing it in some way. In this case, we're identifying what the unique words were, exploiting the characteristics of a Java set, which only keeps unique things. So as it encountered the same words until we tried to put it in the set, it wouldn't go into the set if that word was already there. So we were able to use that characteristic of a set to perform the task we wanted, which was to get the unique words. But the key design thing is that this class is non-visual, and it's outside of the user, the swing piece. In other words, the swing piece uses that as an instance variable, but doesn't bolt it on. So it's sort of loosely coupled. Two other things. You'll notice that when I run it, when it actually first comes up, it actually pops up. This should be in the center of the screen. And here's how you do that. Okay, I did a couple things. One is I set the look and feel here. This is, again, sort of optional. I personally find the Java look and feel dialog boxes to be ugly, and I don't like them. Even the Windows ones look better than the Java ones. But that's my personal thing. If you don't want that, just don't do that. But the other little piece here is how do you center it on the screen when you don't know what the size of the screen is? Well, this is how. First, I can get there's a class called dimension, and the way I get the screen dimension is there's a class called toolkit, and I get the default toolkit, and it has a getter called the get screen size. Now, from what we've covered before, get default toolkit is what kind of method? It has to be a static method because I'm using the name of a class with the method, but get screen size is an instance method because I'm invoking it from an instance. So get default toolkit it actually gets an instance of toolkit, which is an object, and on that I invoke get screen size, which is an instance variable. So again, just sort of keep all that in mind when you're trying to figure out what is going on here. Now, the thing is that, remember the origin is up here. So if I take the width of the screen dimension and the width of my frame, divide it by 2, that will tell me the x location of where to put the frame. And if I take the y, the height of the screen, subtract the height of the frame, divide all that by 2, that will tell me where to put the upper left corner of the frame. So when I run that, regardless of what my screen size is, that will always center my window in the screen. That isn't anything, that's optional. Where you put the thing is up to you. So, okay, so that's